Hello, Bronx Middle School Math. Today we are doing lesson 7, and the goal of this is for you to be able to explain how multiplying and dividing by the powers of 10 changes the values of a number. So how does the place value change when we multiply or divide by the powers of 10? Well, I'm sure you're asking yourself, what is the powers of 10 again? That's not really a phrase we use quite a bit. We don't use that often. You don't use it in everyday language. So it's understandable that we don't know exactly what it means off the top of our head. But let's go over here and see what we have. These are examples of the power of 10. So we have 10, 100, 1,000, and then 10,000. So remember 10 to the power of 1? That's 10. Now 10 to the power of 2, that is 10 times 10, which we know is 100. 10 to the third power, 10 to the power of 3, that's 10 times 10 times 10, which equals 1,000. And our last example here is 10 to the power of 4, which is 10 times 10 times 10 times 10, which gives us 10,000. Now, it doesn't just stop at 10 to the power of 4. You can go as long as you, or as far as you like. I could do 10 to the power of 20. And what that means is that an easy way to do that, so I don't have to do 10 times 10 times 10 20 times, is all I have to do is do, wait 1 second, let me get my marker app out. There we go. 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're still going, y'all. 17, 18, 19, 20. And the reason I know that is because I am increasing 20 place values. So there needs to be 20 zeros all the way, and then 20. That's a pretty big number. Let's see. How many Jeff Bezos do you think this is? That's a pretty solid number. So here would be a million right here. And here's a billion. I don't even know. A trillion. Jeff Bezos. I'm over here. Here's me, Miss Tharp. I'm in the one spot, y'all. So that is what we do with the powers of 10. But y'all know this picture. When I multiply a number by 10, I increase one place value. If I would multiply by 100, I would increase 2 place values. So a quick and easy way to know how many place values you're increasing is count the zeros. 1, 2. So 2 place values. And division. Let's talk about division. So when I'm dividing by 10, I decrease 1 place value. Look. So let's get some examples in. And y'all have seen this picture before. You've seen that plenty of times. But now we're just going into greater detail. So I want y'all to look at this number string. Look at it, know it. Do you notice any patterns? So I wrote down some vocabulary words from Unit 1. Remember, when we do multiplication, we have a factor and a factor. And those multiplied together give us a product. So what do you notice? Any patterns we got going on here? Well, let's go ahead and just try and solve these. So 571 multiplied by 10. Well, if I go here, I know I'm going to increase my place value by 1. So when I'm increasing my place value, that means So when I increase my place value, what that means is that my number is getting bigger. So if I move my decimal to the left, that would become 57 and 1/10. That is clearly smaller than 571. So I know it doesn't go to the left just using, process of elimination and logic. So I'm going to move it to the right. That increases my place value. So 571 multiplied by 10 is 5,710. I'm going to put that over here so it doesn't get in the way of our future problems. $5,710. There we go. And I'm going to put a decimal here to show you show you all aspects of the number. Now we're going to do 571 multiplied by 1. Y'all, I'm not going to waste your time with that. You know that. Anything multiplied by 1 is itself. We're going to move on to 571 multiplied by 1. Oh, I forgot the multiplication sign. Multiplied by 1/10. This is tricky. This, I don't want y'all to get scared. I'm going to write this in a different form. Sorry, that was taking up precious room that we could use. So 1/10, the fraction version of that would be this, 1/10. That is the same thing. But, on this picture, I see what I do with, how I would increase by the powers of 10. But what about when it's a fraction? What does that do? So we just need to change the form. So 571, if I want to make it a whole number, I'm going to change our operation to the opposite. So instead of multiplying, I'm now dividing, and it's by 10. Look at this. I take the denominator, and I change the operation because I was multiplying by 1/10, but now I'm dividing by 10. These are the same thing. 571 multiplied by 1/10 is the same thing as 571 divided by 10. The exact same thing. And that should help us out. That is going to make it easier because I can go back to this chart and go, look, when I divide by 10, I decrease in place value. So I decrease 1 place value. And I know it's 1 place value because how many zeros are in 10? 1. So when I'm decreasing in place value, what would happen if I 571? Okay, so if I move my decimal point to the right, that would be 5,710. That is clearly bigger. That would be increasing. So I need to move, when I'm decreasing my place value, I move the decimal to the left. And that is going to give me 57 and 1/10. Okay, let's go on to our next one. And we have 571 times 100. I want y'all to pause the video and put this in the fraction form. How would I write 571 times, what would be the fraction form? You see how we did 1/10 up here? What would be the fraction form for 100ths? One over 100. Okay, so what do you think the inversion would be? So up here we did divided by 10. What would it be? 571. What would the inverted version be? Divided by, because we got to do the opposite sign of, and then we're going to do the denominator. Divided by 100. And now that we have it in that form, I can go to this and say, okay, look, when I divide by 10, I decrease in place value. So I'm not dividing by 10 anymore. I'm dividing by 100. So I'm going to decrease two place values. And that is because 100 has two place values, two zeros, 1, 2. So if I move it this direction, that's going to become 57,100. That's not smaller. We are decreasing. So my decimal point is going to go 1, 2, giving me 5 and 71 hundredths. Okay, here is our last one. 571 multiplied by 1/1000. Start the video to find out what the fraction version of that would be. There's the fraction version. Now I want you to do the inverted version. Use what we did before. We see that we did divided by 10 because we took the denominator and did the opposite operation. We did divided by 100 because we did the opposite operation and took the denominator. What would be that for this problem? Yep, 571 divided by 1,000. We are going to be decreasing 3 place values. 1, 2, 3. So since I'm decreasing 3 place values, our decimal point needs to go to the left. 1, 2, 3. There it is. And our final answer is going to be 571 thousandths. Okay, let me write that down. 571 thousandths. Okay, so here are our answers. What do you notice about? Do you notice a connection between our factors and products? So we can see as our factors are decreasing, the products are decreasing as well. And they decrease at the same rate. So look, from this product to this one, we divide by 10. 10 divided by 10 equals 1. Well, 5,710 divided by 10 equals 571. Let's go to the next one. 1 divided by 10 equals 1/10. 571 divided by 10 equals 57 and 1/10. So we see that the same difference of our factors can be seen in our products. They change at the same rate. Okay, now we got some fun practice problems. The USPS, United States Postal Service, needs help. They need scholars to buy as many stamps as possible to help them raise money. Each stamp costs a penny. What is the decimal equivalent of that? Well, okay. Let's break this down. I know. Okay, so $1. If I have, let's talk about quarters. I need 4 to make $1. Dime. I need 10 to make $1. So 1 dime is 1/10 of $1. 1/4. Oh, I did the wrong fraction on that one. That's embarrassing. A quarter is worth 25 cents. I apologize. 25 cents. A dime is 10 cents. But a quarter would be 1/4 because you need 4 to make $1. So if you have 1/4, you have 1/4 of $1. Now let's do nickel. You need 20 to make $1. It is worth 5 cents. So if you have 1 nickel, you have 1/5 of $1. Now let's do penny. You need 100 pennies for $1. So 1 cent. If you have 1 penny, you have 1 out of 100. 1/100th of $1. So the decimal form, 1 penny would be 25 hundredths. 1 dime would be 1/10. A nickel would be and then a penny would be so the decimal equivalent of 1 penny is right there. So if I multiplied 1 penny times 100, so I got 100 pennies, I would increase my place value. I'm multiplying by power of 10. 1, 2. I would increase place value 2. 2 place values. I'm increasing 2 place values. So 1, 2, and I would have $1. So they need scholars. The United States Postal Service needs scholars to buy as many stamps as possible to help them raise money. Each stamp cost 1 penny. We know the decimal equivalent of that is 100. You have $1 and 3 pennies. $1.03. How many stamps can you buy? What is the equation you can use to determine that? Well, I know I need $1 equals 100 pennies. And I see I have $1.03. So I can have 100 pennies and then I have 3 cents plus 3 pennies. That tells me 103 stamps. I can buy 303 stamps. Let's look at some other equations that we can use to do that. So this is telling me to do this is what we did at the beginning of the video with the 571, and we were doing it times 1 over 10, and we had to turn it into 571 divided by 10. We're going to do the same thing here, but we're beginning with division, not multiplication. So do the same thing. What's the opposite operation? So I'm going to do 1 300ths multiplied by, and then I'm going to do the denominator, 100. So my place value increases 2. 1, 2, 1, 2. 103 pennies. Let's do that again. Now I got 1 over 100 because if you have 1 penny, you have 1/100th of a dollar. Because you need 100 pennies, or output, it takes 100 pennies to equal $1. So that's why we have 1/100th. So what would be the inverted version of that? I know it's going to be 1/300th, and the opposite sign of the opposite of division, multiplication, and the opposite of 1 over 100 would be 100. How many place values? 1, 2. And am I increasing or decreasing? I'm increasing because I'm multiplying by a power of 10. So 1, 2. So that is going to be 103 pennies. So they have special Avenger stickers, but they cost a dime. What is the decimal equivalent for that? Well, we did that up there. We said a dime, you need 10 dimes to make $1. 10 dimes equals $1. So if you have 1 dime, that equals 1/10 of $1. The decimal form of that, right here. That 1 dime, 1/10. Because you need 10 total dimes to make $1, and if you only have 1, that's 1/10. So I now have $2.50. How many Avenger stamps can you buy? So I am dividing 200 or $2.50 divided by 10. Oh, my bad. I meant to make that a decimal. My bad. Because it's 1/10. Excuse me. Because that's the price. 1/10 is the price. And $2.50 is the total money I have. So how many stickers? I think we need to do the inverted version because it's tough for me to do decimal, like move the place value based on decimals. So let's change it up. $2.50. What would be the opposite operation of division? Multiplication. And we know 1/10, the fraction version of that, is 1/10. So I'm going to take the denominator, multiply by 10. So I am increasing my place value by 1. And I'm doing that because I'm multiplying by a power of 10. And there's 1 0, so I'm increasing 1 place value. Boom. So I can buy 25 stickers. We're going to do a little game now, and it's going to be guess my number. So our new friend, our new teacher, Miss Herson, she's thinking of a number. It's a 2-digit number. That's the clue she gives us. 2 digits. So let me, no. So it's a 2-digit number. So it can be in the tenths and ones place, or it could just be the ones and tenths place, or it could be the tenths and hundreds place. We don't know. All we know is that it's a 2-digit number, and we need to use these clues to figure out which number and the place value. So the digits and the place value. So let's begin with the first clue. When this mystery number is multiplied by 10, there is a 1 in the hundreds place. Okay, so we have the original number, and when it was multiplied by 10, there's a 1 in the hundreds place. So what do we need to do? That tells me that there's a 1 in the hundreds place. After I multiplied by 10. So that means our place value increased and that the 1 used to be a 1 place value smaller. So before, whoop, I don't know what's happening. Before we multiplied by 10, the mystery number was in the tens place because it increased a place value when we multiply by 10. So I need to find the original number. I need to put it back to where it was, which is in the tens place. So a 1 in the hundreds place, we're not changing the digit. We're just changing the place value. So it was in the tens place. So I'm going to put it right here. Okay, our next clue. When you multiply this mystery number by 1/10, you get 7. You get 7 in the tens place. Okay, so what is the opposite of that? Multiply this number by 1/10. You get a 7 in the tens place. So So that is telling me I need to do the opposite. So 1/10 is the same as that. And multiply the opposite would be division. So if I now have a 7 in the tens place. So I need to do the opposite and divide by this denominator by 10. Wait, okay, I feel so dumb. I read that question completely wrong. Or I read the clue completely wrong. I'm sorry. I did not read that clue correctly. So when you multiply this mystery number, okay, I did this wrong. I apologize. So what we're doing is the mystery number is here, and we are multiplying it by 1/10, and then we get a 7 in the tens place. So what we're trying to do is find this value, and that's going to be the same value as the mystery number. I apologize. I did that wrong, but I caught myself. Never be afraid to admit when you're wrong, y'all. So what number do I need to multiply by 1/10 to get 7/10? Well, that's easy. Because any number multiplied by 1 is itself. So if I do 7 times 1/10, that will equal 7/10. So 7 is our final mystery number, and 7 is in the ones place. So I'm going to say that Miss Herson's mystery number was 17, and that fits the 2-digit rule that we had. It needed to be 2 digits, and 17 is 2 digits. Let's go check our answer. Oh, I went too far. Okay, let's read. What numbers can I multiply by 10 to get me to the hundreds? 10 times 10 equals 100. 1 is in the hundreds place. There we go. All right, and we did. We got 17. All right, good job, y'all. Let's go on to our next and last problem. Now we're doing Ms. Ramos's secret number. So we have 3 clues. Oh, and it's a 3-digit number. So let's use the clues to figure out this secret number. So here I have our number line. We have hundreds, tens, ones, tenths, hundredths, thousandths. Okay, and it just needs to be a 3-digit number. So let's read these clues. When this mystery number is divided by 10, there's a 3 in the ones place. When you multiply this mystery number by 1/10, you get a 7 in the hundreds place. The last digit is the product of 1/100ths multiplied by 700. What is Ms. Ramos's secret number? Pause the video and start it when you think you have the correct answer, and then we can check our work. Okay, so let's begin with the first clue. When the mystery number is divided by 10, there's a 3 in the ones place. So we need to come up with the formula for here. I'm going to label this clue 1, clue 2, clue 3. So clue 1, the formula we need to do is our mystery number. when it's divided by 10, we have a 3 in the ones place. So I would need to figure out what number divided by 10 equals 3. 30. 30 divided by 10 equals 3. So the 3 is in the tens place. Because if I move this over, three times 10 equals 30. So that means that this 3 was originally in the tens place, which is why we put it in the tens place. Okay, let's go on to clue number 2. When you multiply this mystery number by 1/10, you get 7 in the hundreds place. So that is telling me when I have a mystery number multiplied by 1/10, I get 7 hundredths. Okay. So what number do I need to multiply? Well, I know 7 and 1. So anything multiplied by 1 is going to be itself. So I know that one number of the mystery number is going to be a 7. But is it going to be that 7 tenths or 7 hundredths? It is going to be 7 tenths. So this is our mystery number. This is the number that we are going to put right there. All right, let's go into our final clue. The last digit is a product of 100 multiplied by 700. That's pretty easy. So 700 multiplied by 1 over 100. And remember, I'm not too good at the decimal or the fraction version, so let's switch it. So I am decreasing my place value by 2. When I decrease my place value, I move the decimal point to the left. So I have a 7. So a 7 is our final component or our final digit of the mystery number. So let's put that in there. So for our final answer, we should get 37 and 7/10. These are tricky problems. They're definitely some national treasure puzzle type things that can be frustrating, but you gotta have patience and think through it. So let's check, well, before I give that lecture about humility and patience, let's check to see if I got it right. And we did, we got it correct. 37 and 7/10. Pause this slide to see if the explanation matches what you got. All right, y'all, this is the end of lesson 7. I have some supplementary videos from some other YouTube channels in the description below, so check those out.